Okay, today I'd like to start with this warm up for the law of sines, just to give us a little bit more practice with this. So try this one, pause the video, work through it, and then check your answers. Okay, so on this one, we've got this triangle here, so I'm going to sketch this out. We've got sides A, B, and C. Side A is 105, so that's going to be opposite angle A. Side B is 82, and angle A is 133 degrees. So what we have is side-side angle, and we know that that is the ambiguous case, the one that we have to decide if we have 0, 1, or 2 triangles that we're going to work with. So when I look at this, I like to kind of organize my information. So I've got angle A is 133 degrees and side A is 105. Angle B we don't know. Side B is 82. Angle C we don't know, and we also don't know side C. So when I look at this, I clearly have all the information for letter A. So that's going to be one of the ones that I have to use. I'm going to use sine of A over A. And then since I have part of the information for B, I'm going to do sine of B over B. So that's going to be sine of 133 degrees divided by 105. That's going to be equal to the sine of angle B over 82. So we want to then cross multiply. Okay, we want to get B by itself, so the first step in that process is to get rid of this 105. And then we also want to get rid of sine, so we'll do that by taking the inverse sine of both sides. Okay, so if I take the inverse sine of sine, I'm just going to have B. So when I put all that in my calculator, I'm going to get an answer that is 34.83. Okay. If we're going to round these to one decimal place, then we would say 34.8 for that one. Okay, so we need to check and see about, this is our first quadrant angle, so we need to check on the second quadrant angle. So 180 minus 34.83. Okay, if I put that in, I'm going to get 145.17 degrees. Okay, so my angles for angle B are either 34.8 or 145.17. So when I go to find angle C, so when I'm looking for angle C, I know the angles of a triangle are 180, so I'm going to start with 180. I'm going to take away the angle that I know, which is 133. I'm going to take away the angle that I just found, the 34.8. And when I do that, I'm going to see that my angle C is going to be 12.17. Okay, so again, rounding to one decimal place will be 12.2. Okay, if I'm going to look at the second possibility for this angle C, I'm going to have 180 degrees, which is what we always start with a triangle. I know angle A is 133, and my second angle B was 145.17. Well, we can clearly see that this is too much. There's not going to be any angle left for the third angle, so we're going to have no triangle for this one that's formed. So we only have the one triangle that we have to go ahead and find. So we have one side C that we need to find. So I'm going to use the sine of A over A equals the sine of C over C. Cross multiply. Divide by the sine of 133. And we're going to get side C is 30.27. So if we're rounding to one decimal place, we'll have 30.3 as our answer. So one thing, if you happen not to be getting a lot of these answers, it may very well be that your calculator's in the wrong mode. So take a minute and if you're having trouble that way, and double check that you're in degree mode for your calculator. Okay, so today we're going to finish up chapter 6 and we're going to look at the law of cosines. I actually think law of cosines is an easier topic just because we don't have ambiguous cases to have to deal with. It's more just algebra of grinding out formulas, and hopefully you'll find this to be a little bit lighter topic today. Okay, so we use law of cosines for some of the cases that are left. So in Case 1, we looked at the angle side angle or the side angle angle case, and that was one we used law of sine on and had only one set of answers. The second case was the ones where we had the side side angle, and that was, we also used law of sine, but we had the ambiguous case where we had to decide, was there no triangle, one triangle, or two triangles. So today we're going to look at the side angle side case, and that's two sides in the included angle, and that's going to require us to use law of cosine. And the other case we're going to look at today is the three sides being given, which is the side, side, side case, and use law of cosines for that one as well. Okay, so what law of cosines tells us is that in any triangle ABC, then a squared is going to be equal to b squared minus c squared equals 4b, equals 2bc cosine of a. So if I'm looking at this, there's a couple things I want to point out. One is that they should remind you of the Pythagorean theorem, the first part of it. And in each case here, you're going to start out with, like, here you've got b squared plus c squared minus 2 times these two sides, so b and c, cosine of the angle that's over here by itself. So there's a pattern to these. It's not three different formulas that you're going to have to memorize. You just need to understand that whichever side is here, its angle is going to be over here. And the two sides that are here are going to be the ones that make up this value, these values here. Okay, so what happens is we actually have the Pythagorean theorem is a special case of the law of cosines. So I want to show you that by starting here with this right triangle, if I can get a right triangle drawn. Okay, so we've got side A, side B, and side C. Okay, so if we're going to look at this, we know that the Pythagorean theorem is a squared plus b squared equals c squared, but I want us to actually start with the law of cosine. So by the law of cosine, we're going to have, I'm going to say c squared. Since this is our right angle, this is the angle I want to focus on, so I'm going to use the one that starts with the c squared, because this would be angle C, this is angle A, and this would be angle B. So c squared is going to be, by the law of cosines, we've got a squared plus b squared minus 2ab cosine of c. So if I start out with this one, what I'm going to do is I'm going to substitute in for the one angle that I know, which is the 90-degree angle. Okay. So thinking back to your unit circle, 90 degrees is here. The coordinates would be 0 and 1. So the cosine of 90 degrees is actually 0. So I'm going to have c squared equals a squared plus b squared minus 2ab times 0. So all that is 0. So 0 times anything is 0, so that whole expression goes away. And here we have our Pythagorean theorem. So again, the Pythagorean theorem is a special case of the law of cosines when you have a right angle in your triangle. We know that Pythagorean theorem only works for a right triangle, but law of cosines works for any triangle. It does not have to be a right triangle for it to work. Same with law of sines. So law of sines and law of cosines can be used for any triangles, any triangle, and then the SOHCAHTOA with the opposite adjacent hypotenuse can only be used for your right triangles. Okay, so here's one to get us started. This one we're actually provided all three sides. So this is the side case, and we're going to have to use the law of cosines for that. And I'll kind of show you why. If I organize this triangle here, we've got angle A, angle B, angle C, side A, side B, and side C. So I know all of these. I know A is 5, B is 8, C is 12, but I don't know any of these. So in order to use law of sines, I would have to have known both values for one of my letters or been able to very easily find it. So sometimes you might have been given two angles and you could easily find the third angle and therefore still use law of sines. But here I don't have any of that, so I don't have any choice but to use law of cosines. I will say that this is just how you start the problem. So once you get it started and you find one of the other values, then if you really just prefer law of sines, then you can go and use that. So you don't have to do the entire problem using law of cosines or the entire problem using law of sines. You just have to start the problem in this way. Okay, so here let's just start by finding angle A. So if I need to find angle A, then I'm going to need to choose the law of cosine formula that has the capital A in it. And that's going to be this one, that's A squared equals B squared plus C squared minus 2BC cosine A. Okay, so I'm going to plug in my A, B, and C. So I'll have 5 squared equals 8 squared plus 12 squared minus 2 times 8 times 12 times the cosine of angle A. Okay, so we've got 25 is 64 plus 144 minus 192 times the cosine of A. If I add these two together, I get 208. Right, the number one mistake I see people make using the law of cosines is to combine these two numbers together. They don't combine together because 208 is standing alone and the 192 is multiplied to the cosine of A. So we can't combine these two together. So if I'm left to solve this for A, the first thing I want to do is to take the 208 to the other side. So when I do that, I get negative 183. I'm going to divide by negative 192. So my cosine of angle A is 0.95312. So definitely carry it quite a few decimal places here. So now I'm going to do the inverse cosine of 0.95312, and that's going to give me angle A. So I do the inverse cosine of both sides here. So angle A is going to be 17.6 degrees. Okay, so now we're ready to go ahead and find angle B. And so we're going to basically be repeating this process using angle B instead of angle A. So if we're going to be finding angle B, then that means we're going to use the law of cosine formula that has the capital B in it, which is the one that starts with the B squared. So I'll have B squared equals A squared plus C squared minus 2AC cosine of angle B. So when I plug everything in here, B was 8, so I'll have 8 squared, A was 5, C was 12, so we're just repeating this process that we just went through. Okay, we're going to subtract our 169. So that's going to leave us with negative 105. Divide away this number. And then to get rid of cosine, we're going to do the inverse cosine of both sides. So B is going to be 29.0 degrees. Okay, so we can go back and put in the 29.0 degrees here for angle B. The good news is you don't have to do law of cosines a third time because we can go back to the fact that the sum of the angles of a triangle is 180 degrees, and we can quickly find angle C. So if I do 180 minus the 17.6 that we found for angle A minus the 29.0 that we found for angle B, then I'm going to find the angle C is 133.4 degrees. Okay. So now we have all the angles of our triangle and we're done with this one. So no ambiguous cases. It's just really grinding out the algebra to do these. Okay, here's one that we're going to practice with. This one has two sides and an angle, and we're going to solve for this. Okay, sketch out the triangle that we're working with here. Got A, B, and C. So side A is 3, side B is 4, and angle C is 53 degrees. And there might be a tendency to think, oh, this is a 3, 4, 5 triangle, and it would be if it was a right triangle, but we don't know that it's a right triangle. So because we don't know that it's a right triangle, we can't jump to the conclusion that our other side is going to be 5. So we're going to use this information here. So what we have is we have a side, an angle, and a side. So we have the side angle side case, and so like I said, I always like to organize myself here so that I can keep track of what I have and what I'm looking for. So on this one, I have side A, I have side B, and I have angle C. So you can see from this that clearly law of sines would not be a candidate because I don't have both pieces of information for any of the letters. So I'm going to have to use law of cosines to do this. Looking at this one, when I see this, the first thing I'm actually going to do is I'm going to go ahead and find this side C because I'm going to need that when I go to start finding some of these other angles here. So looking at side C, I'm going to use the one that starts out C squared equals A squared plus B squared minus 2AB cosine of C. So C squared is going to be 3 squared plus 4 squared minus 2 times 3 times 4 times the cosine of 53 degrees. And the good news is these go much quicker than the other ones. When you're given your angle and you're using law of cosine, it's an easier process. So C squared, I'm just going to literally type all of this in my calculator, and I'm going to get 10.55643944. Again, always carry it to quite a few decimal places, 5 or 6 at a minimum. Okay, we'll take the square root of both sides, and when we do, we're going to get C is 3.25 for our answer there. Okay, so 3.25. So that's side C. Now we're left with finding angle A and angle B. So we'll just pick one of these. So if I'm going to find angle A, then I'm going to need to use the one that starts out A squared equals B squared plus C squared minus 2BC cosine of A. Okay, so this is the one we're going to use if we're solving for angle A. So I'm going to plug everything in. A is 3, B is 4, C is C is 3.25. That's the one that we solved for. And then we're going to have the cosine of angle A. So we'll have 9 is going to be 16 plus 10.5625 minus 26 times the cosine of angle A. I'm just going to combine this into one step. I'm going to do 9 and then subtract 16 and 10. So we get negative 17.5625 equals negative 26 times the cosine of A. We want to divide away this negative 26. So we get 0.67548 is equal to the cosine of A. So A is going to be the inverse cosine, because remember we need to use inverse cosine in order to get rid of the cosine. So I have inverse cosine of 0.67548. And so angle A is going to be 47.5 degrees. Okay, so we'll come up here and we'll put in our 47.5 degrees. And then for angle B, we've got a couple options. One, we can go back and do, since we know the sum of the angles of a triangle is 180, we'll do 180 minus 47.5 minus 53. And when we do that, we're going to get 79.5 degrees for our answer. Okay, so that's going to go in here. The only thing I would caution you about by doing this is that you are relying on this having been a correct answer. So, if you miss this one, and then you're probably also going to miss the second angle that you're finding there. So just be really careful about that and make sure that you do that correctly. If you're not sure about it and you want to go through the process using law of cosines to find angle B, you could do that and then add all your angles up to make sure that they equal 180, and that would be a good check on the process. Okay, so to end today, what I would like to do is to have you consider which method you would use to start the problem. Like I said before, you don't have to finish the problem using that. You just have to use it to start it. So look at each case and decide whether it will be a law of sine case or a law of cosine case. And then I'll advance the screen and we'll check your answers. Okay, the first one here, we've got angle, side, angle. So angle, side, angle is always going to be law of sines. It's not the ambiguous case, so we wouldn't have to worry about deciding how many triangles, but it is the law of sines. This one would be side, side, side. So side, side, side is the law of cosine. Here we have angle, side, angle. So angle, side, angle again is law of sine. And here we have side, 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 which is law of cosine. This one, if we look at it, we have angle, 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 side, which is also law of sines. So angle, angle, side. These, I'll give you another minute or two to check and see which one you think it would be. Okay, this one we would have angle, side, angle. So angle, side, angle is law of sines. This one we're going to have side, side, angle. So this would be the law of sines, and it would also be the ambiguous case that you'd need to check for the possibility of no triangles or two triangles. This one, if we look at it, is going to be angle, angle, side. So that's a law of sines. And this one is going to be side, angle, side. You go side, angle, side, so that's law of cosine. Okay, so looking at one other thing here with the area of a triangle that I wanted to go over, sometimes using the law of cosine, we can actually find the area of the triangle when we only have the lengths of the three sides. So this is an application of the law of cosines. And the law of cosines basically gives us what's called Heron's formula. Heron's formula, you can find the area of a triangle when you only have the sides and you don't have any of the angles to work with. You have to use something called the semi-perimeter of the triangle, which is basically you add up the sides of the triangle and divide by 2. So semi meaning half of a perimeter of the triangle is what S is going to be, and then you're going to substitute S into this formula here. Okay, so if we look at this problem here, we've got a businessman wishes to buy a triangular lot in a busy downtown location. The lot frontages on the three adjacent streets are 125, 280, and 315 feet. Find the area of the lot. So it's not unusual that you wouldn't necessarily know these angles, and you would know the sides in a case like this. So if I want to find the area of the lot, then I'm going to have to use that semi-perimeter that we talked about, which was 1/2 of A plus B plus C. So if we add all of these up, okay, if we add our sides up here, we're going to have, for the semi-perimeter, we're going to have 1/2 and then 125 plus 280 plus 350 is going to give me 360 for the S. So going back to Heron's formula and plugging in here, we know that our area is going to be the square root of the S we just calculated was 360. So 360 actually goes in quite a few times here. And then we're going to go back and we're going to put in our sides. So our sides were 125, 280, and 315. Okay, so then we'll have our answer once we put all this in the calculator. So we get 17,451.6. And we want to consult with our units on this one. So it was in terms of feet. So area is going to be feet squared. And we could definitely go ahead and round this to 17,452 feet. More than likely on WebAssign, it's going to be asking you to round to the nearest foot for your answer. Okay, so that concludes chapter 6. We'll be stopping and testing after chapter 6 again. So we're going to do a study guide and review sessions coming up and then test in a couple days. So thank you and have a good day.